Hello again, night thinker. Tonight, we're going to ask the questions most science classes skip. Not loudly, not with anger, but gently, like brushing dust off an ancient book. They say evolution explains everything. But what if the evidence isn't so clear? Tonight, I'll share with you 100 scientific reasons why the story of evolution might not be the truth. Or at least, not the whole truth. So rest easy. You won't need a lab coat. Just your mind, your wonder, and maybe a blanket. Let's begin. Reason 1. The unexplained origin of life's first cell. We've talked about evolution, how one thing becomes another, how species adapt and survive. But what we haven't asked, what most textbooks quietly skip over, is the most important question of all. Where did life come from in the first place? Not how it changed, but how it began. You see, evolution starts with life, with cells already swimming in some primordial sea, with DNA already humming instructions, with metabolism already metabolizing. But where did the first cell come from? The first breath? The first spark? This isn't a religious question. It's a biological one. And right now, no one has an answer. Let's go back in time. Billions of years ago, Earth was young. Volcanoes boiled the seas. Lightning forked across black skies. Ammonia, methane, hydrogen, water. Some say this primordial soup was the recipe for life. That random molecules collided again and again, until one day, somewhere by chance, life emerged. A single-cell organism. Simple. Self-replicating. Alive. That's the story. The mythos of materialism. But there's a problem. Actually, there are many. Let's begin with the simplest cell. A bacterium. Not complex. Not evolved. But even that requires over 250 proteins working in harmony. A cell wall to protect it, a system to copy its DNA, a way to turn nutrients into energy, and an instruction manual millions of letters long. If any of those parts are missing, life fails. Now imagine assembling that from random molecules in a lightning-charged puddle. Proteins don't form easily. They require specific chains of amino acids folded precisely in three-dimensional shapes. One wrong fold? Useless. And DNA? It's even worse. It can't build itself. It needs enzymes. But those enzymes are built using DNA. So which came first? The instructions or the builder? The blueprint or the factory? It's the biological version of a chicken and an egg. And no one has solved it. Experiments have tried. You may have heard of the Miller-Urey experiment, a famous 1950s setup that produced a few amino acids by zapping gases with electricity. But amino acids aren't life. They're ingredients. It's like claiming lightning hitting flour explains the existence of sourdough. It's a start, but not even close. Despite decades of research, no scientist has ever produced life from non-life. Not in labs, not in nature, not even artificially with all our modern tech. The odds? Astronomical. Physicist Fred Hoyle once likened it to a tornado sweeping through a junkyard and assembling a Boeing 747. Some try to soften the blow by calling it abiogenesis, a fancy word for life from non-life. But renaming a mystery doesn't solve it. Even Nobel Prize-winning biologist Francis Crick, one of the men who discovered DNA structure, admitted that the origin of life on Earth seems too unlikely. So what did he propose? Panspermia, the idea that life came from elsewhere, maybe riding on comets or sent here intentionally by ancient intelligence. That's right. Even one of the world's most respected scientists suggested life may have been seeded here. Why? Because Earth didn't provide enough time or conditions to generate life randomly. The ingredients weren't enough. The spark wasn't enough. The randomness wasn't enough. Now pause. That doesn't prove a creator. It doesn't prove divine fingerprints. But it does whisper something important. That life may not be an accident. It may be an arrival. Life, real, replicating, self-aware life, may be the result of intention, of programming, of something beyond molecules and lightning. And if that's true, then evolution didn't start at the beginning. It started in the middle, and the origin remains unknown. Not just unknown, unspoken, because in the halls of academia, to question the origin of life is to tread on sacred ground. To ask, could there be intelligence behind this, is to risk ridicule. But here, in this soft, quiet space, you're safe to wonder. So wonder with me. Close your eyes. Picture that first cell, humming, dividing, becoming. It didn't crawl from mud. It didn't stumble from chaos. It appeared with code, with structure, with purpose. And the more you zoom in, the more it looks like design. A design with no known origin. A life with no known author. Reason 2, the fine-tuning of the universe, the anthropic principle. Now we wonder about something curious. Something scientists call the anthropic principle. A fancy phrase, but its meaning is simple. It says this: the universe appears to be perfectly calibrated for life. Now, let's be clear. Not just convenient for life. Not just supportive of life. Perfect. Let's wander together through a few examples. If the strength of gravity were just slightly stronger, stars would burn too fast. Galaxies wouldn't form. Everything would collapse too soon. If it were weaker, no stars, no planets, just floating dust. If the electromagnetic force varied by the tiniest fraction, atoms wouldn't hold together. If the mass of the proton were different by 1 part in 10 to the 15th power, or 10 raised to the power of 15. In terms of its value, it equals 1 quadrillion, which is 1 quadrillion. The universe would be sterile. And then there's carbon, the element life is made of. It exists only because in stars, certain nuclear resonance levels align with eerie precision. If they didn't, no carbon, no biology. Physicist Freeman Dyson once wrote, "It seems as if the universe knew we were coming." Even the formation of water, the solvent of life, requires a perfect balance between oxygen and hydrogen bonding. Time after time, parameter after parameter, the story is the same. Life should be impossible. And yet, here we are. Evolution tries to explain how life adapts, but it cannot explain why the universe came preloaded with all the conditions life would need before life ever existed. It's like arriving at a strange hotel to find the room is exactly your favorite temperature. Your favorite music is playing, your name is embroidered on the towels, and the hot meal has already been delivered. Your favorite dish. Coincidence? Maybe. But when the coincidences start stacking up, you start to wonder, did someone know we were coming? Now, there are theories. Some scientists say the reason everything looks designed for us is because we're here to observe it. If things weren't this way, they argue, we wouldn't be here to complain. This is called the anthropic illusion. But is it a real explanation, or just a philosophical shrug? Others propose the multiverse, that perhaps there are infinite universes, each with different laws of physics, and we just happen to live in one that allows life. But here's the thing. We have no evidence for other universes. We can't see them. We can't measure them. We can't test them. The multiverse isn't a scientific model. It's a story. A way to escape the unsettling idea that maybe, just maybe, things are this way on purpose. Because if the universe was designed, if it was fine-tuned for life, then someone or something tuned it. And that is not a comfortable idea for everyone. But here, we're not chasing comfort. We're following wonder. So let's imagine, just for a moment, that the universe is not a cosmic accident, that life is not the rare result of chance and chaos, but the reason the universe exists at all. What if all those constants and ratios, the speed of light, the Planck length, the strength of nuclear forces, were set like knobs on a control panel at a mind? What if the stage was set not just for hydrogen and helium, but for hope and hunger and heartache? What if the whole show was built so someone like you could someday sit beneath the stars and ask, why am I here? That doesn't require religion, or dogma, or blind belief. Just awe, just silence, just enough honesty to say this universe feels not random, not meaningless, but musical. And music doesn't write itself. Reason 3, the origin of morality. Where does morality come from? Not laws, not culture, not social norms, but the deep feeling in your chest that some things are right and some things are wrong, that it's wrong to betray, that kindness is good, that harming the innocent just feels evil. Where did that come from? Evolution says morality evolved for survival. That being good to others helped us form tribes. That guilt, love, loyalty were just tools to keep the herd together. Maybe. But let's test that story. If morality is just evolution, if it's merely a trick of the brain to keep us alive, then it has no real weight. It's just a survival hack. Helping an injured stranger? Just biology. Risking your life for truth? Just faulty wiring. Loving your child more than yourself? Just chemical instinct. But deep down, does that feel true? You felt it. That invisible line inside you, the one that burns when crossed, that ache when you lie, the way your stomach drops when you see cruelty, the way your chest expands when you forgive. You didn't choose that code. It was written in you, like DNA. Somewhere inside, beneath flesh, beneath thought, is a moral compass. But if evolution is blind, unthinking, without purpose, then why would it write morality? Natural selection favors power, efficiency, survival. But morality, often it's inefficient. It demands self-sacrifice. It asks you to speak up when silence is safer, to protect others when escape is easier. People throughout history have died for ideals, not because it helped them survive, but because it was right. Evolution struggles to explain that. Now, let's go deeper. Your body is built by DNA, a 4-letter code with 3 billion base pairs. It programs your cells, your structure, even your temperament. But DNA doesn't just build bodies. It also builds brains, and brains carry thoughts, and thoughts carry values. Could it be that hidden in those twisting spirals of code is not just biology, but something more? A whisper of design, of intent, of conscience. Let's think again. If humans evolved from lower animals, randomly, without guidance, then morality should have evolved randomly too. Different in every culture. Chaotic. Subject to whim. And yet, all over the world people know murder is wrong. Lying destroys trust. Love protects. Justice matters. These aren't preferences. They're truths, recognized even by children. Anthropologists find them in every society. Not perfectly lived out, but universally known. As if the rules were built in. Evolution didn't have to write those rules. It could have made us cold, cunning survivors. It didn't have to invent empathy. But here we are, weeping over stories, sacrificing for strangers, carrying burdens for those we love. Something deeper than evolution is at work. And if evolution can't explain where that moral code came from, maybe it didn't write it. Maybe it was received from a higher law, a higher mind, a source beyond atoms and instincts. This doesn't prove a religion or a scripture. It simply invites wonder. Because if you have a compass inside you, pointing not north, but toward justice, mercy, truth, then maybe you were meant to follow it. Not for survival, not for gain, but because it's good. And that changes everything. Reason 4, the information in DNA. DNA, you've heard of it. But have you ever truly listened to it? Because DNA isn't just a molecule. It's a language, a code. 4 letters, A, T, C, G, repeated and arranged into precise instructions that tell your body how to build itself. How to grow skin. How to beat a heart. How to make neurons. How to think. How to be you. But here's the quiet secret no one talks about. Language doesn't come from chaos. Every language needs a speaker. Every code needs a coder. Every instruction needs a mind behind it. Let's pause here. Evolution says that DNA emerged through billions of years of trial and error, that random mutations, filtered by natural selection, produced this exquisite instruction manual we all carry inside. But there's a problem. Random mutations don't create meaning. They create noise. Imagine taking alphabet soup, shaking it in a jar for 1 billion years, and expecting it to write Shakespeare. DNA isn't a few lucky words. It's volumes of precise syntax, grammar, sequencing, and error correction. A single cell in your body contains more organized information than the entire Encyclopedia Britannica, and the entire human genome. It could fill 200 printed books, each 1,000 pages long. But more than that, this code doesn't just sit there. It's read, transcribed, translated, executed. I've built in molecular machines that know exactly what to do. Somehow, the instructions and the machinery both arose together in perfect tandem, like having a book and a reader appear at the exact same moment. Science doesn't yet know how that's possible. Even the world's most powerful computers struggle to mimic the elegance of how DNA copies, repairs, and folds itself with nearly zero error. And folding matters. A protein must fold into exactly the right shape to do its job. Miss just one amino acid, the whole structure collapses. Disease follows. Sometimes death. Yet your body folds billions of proteins every day perfectly. No one programmed that consciously. Or did they? If evolution is just a blind watchmaker, fiddling without direction, how did it write syntax? How did it invent recursion, regulation, epigenetics? These aren't just accidents. They're architecture. Now think about this. If we found a tablet on Mars, covered in symbols that repeated with meaning, we wouldn't say, that's just erosion. We'd say, someone intelligent was here. So why do we see the same complexity in DNA and call it random? Some scientists have quietly asked that question. In 2013, a team of physicists and biologists found patterns in genetic code that mirrored error-correcting codes used in advanced computer systems. The same kind of math you'd find in spacecraft communication. Not invented by humans, but already embedded in our cells. Almost as if the system was designed to preserve itself from corruption. Like it knew how precious the message was. Now breathe. Let that settle in your chest. We're not saying evolution is worthless, or that science is wrong. We're simply noticing that the deeper we dive into the cell, the harder it is to believe that all of this was an accident. Information theory says that information comes from intelligence, not randomness. Codes do not write themselves. Languages do not emerge from noise. Messages do not appear without a messenger. So maybe, just maybe, life's origin isn't accidental. It's intentional. Maybe DNA is not the product of survival, but the signature of something greater. Something that wrote you. Reason 5, the missing link in human evolution. Where's the missing link? Not just any link, but the link. The one that connects us to everything before us. The invisible bridge between ape and man, between instinct and intellect, between survival and story. Let's go back. For evolution to work, there must be transitions. Species don't leap. They drift. They morph. Tiny changes over immense time, slowly building new forms. So if humans evolved from earlier primates, where are the gradual steps? Where are the in-between beings? Half standing, half thinking, half speech, half tool, half vision, half everything? Where are they? Now, some will say, they're in the fossils. Let's look. In 1859, Darwin himself admitted the fossil record was a problem. He expected future digs to uncover countless intermediate forms. Transitional fossils. Evolution's breadcrumbs. But over a century later, the record still whispers. Not silence, but uncertainty. Yes, there are fossils that suggest earlier forms. Australopithecus, Homo habilis, Homo erectus. But they don't form a smooth line. They form a scattered puzzle with missing pieces and overlapping timelines and unexplained jumps. Imagine a movie, but only every 10th frame is visible. You guess what happens in between, but you wouldn't know. That's what we have with human evolution, a fossil slideshow with important scenes missing. The famous Lucy fossil, for example, often cited as our ancient grandmother, was about 3.2 million years old, but her curved toes and long arms suggest tree-dwelling. Other fossils from the same period appear more advanced. So who came first, and how? The truth? The missing link hasn't been found. Because it may not exist, we assume a smooth ladder of progress from single-celled to fish to mammal to man. But the evidence often looks more like a bush, or a tangle, or a set of sudden appearances. In fact, there's a name for this: punctuated equilibrium. It's the idea coined by paleontologists Gould and Eldridge that species don't evolve slowly. They appear suddenly, rapidly, with no known ancestors. Sound familiar? The Cambrian explosion was one such event. Dozens of complex life forms with eyes, shells, limbs just appeared, as if someone opened a curtain on a stage full of cast members who were never seen rehearsing. The same strangeness surrounds humanity. Our brains tripled in size, our vocal cords evolved, our behavior changed, and it happened fast. Faster than any known evolutionary pressure would predict. So scientists are left with theories, stories, speculations. Some suggest alien seeding. Others propose environmental shocks. Still others quietly admit we don't know. And here's the gentle truth. It's okay not to know. It's okay to question the tidy museum diagrams, the smooth flowcharts in school books, the iconic image of the ape slowly rising into man. Because evolution isn't that simple. It isn't that clean. And maybe it never was. Now breathe. You are not less evolved. You are not more evolved. You are something else entirely. You think about thinking. You create art from silence. You dream in symbols. You grieve at abstract loss. You imagine the infinite. These are not survival traits. They are spiritual ones. They don't fit into Darwin's box. They don't come from natural selection. They feel imported, inherited, gifted. So maybe the missing link was never meant to be found. Because maybe we're not the next rung on a ladder, but a different kind of being altogether. Born from dust. Yes, but perhaps touched by something more. Reason 6. The mathematical improbabilities of protein formation. Because while the story of evolution paints a poetic picture, fish becoming reptiles, reptiles becoming birds, life inching upward like ivy on the tree of time, math often tells a different tale. Not an angry one, just an inconvenient one. Because when we begin to calculate the odds, to count the steps, to ask not just what happened, but how likely it was, we find that some numbers don't whisper possibilities. They whisper impossibility. Let's start small. A protein. Just one. Imagine a string of amino acids, 20 types to choose from, folded into a perfect shape. Even one minor change in sequence or fold, and it may cease to function entirely. Now, the average functional protein in your body has about 150 to 300 amino acids. Let's call it 150. To form a specific sequence of 150 amino acids, randomly selecting each from a set of 20, you're looking at odds of 1 in 20 to the 150th power. That's 1 in 10 to the power 195. That's a 1 followed by 195 zeros. For comparison, the number of atoms in the entire known universe is estimated to be around 10 to the power 80. Now remember, you don't just need a protein. You need thousands, and not just in any order, but precisely coordinated, interacting, timed, regulated. And yet, we're told this complexity arose by tiny random changes filtered by survival. But even survival needs a starting point. A partially built protein doesn't help. A protein without the right folding mechanism is just goo. A single error in folding can lead to diseases like Alzheimer's. So, where did the first correct folds come from? Reason 7, the problem of genetic entropy. Let's turn to mutation rates. A typical mutation rate is about 1 mistake per 100 million DNA letters per generation. That's slow, purposefully slow, because too many mutations and an organism breaks down. This introduces a new puzzle. If mutations are rare and most are harmful or neutral, how does enough beneficial change accumulate to construct an entirely new organ? A wing, an eye? Darwin imagined millions of years would do the trick. Time, the great sculptor. But time, like money, only helps if you're spending it efficiently. And random change is not efficient. Imagine trying to improve a poem by tossing random letters at it. Sure, eventually, maybe you'll get Shakespeare. But will the poem still work along the way? If one change ruins the grammar and the next ruins the rhyme, how many missteps can you make before the whole thing collapses? Let's move to genetic entropy. This is the idea proposed by scientists like Dr. John Sanford, that mutations accumulate over time, not build upward, but erode downward, because most mutations, even if not immediately deadly, are slightly harmful. And natural selection, especially in complex organisms like humans, isn't powerful enough to eliminate all of them. So generation after generation, the genome doesn't improve. It decays. Like a photocopy of a photocopy, the signal blurs. This is not just theory, it's observed. Each human child inherits around 100 new mutations, and while we survive, those errors accumulate. Now, pause. If evolution is supposed to explain how we climbed upward from bacteria to Beethoven, why do the numbers suggest a slow drift downward? And if even our most error-correcting mechanisms can't stop entropy from gnawing at our genes, how did life ever climb the ladder in the first place? Reason 8. The waiting time problem for coordinated mutations. This brings us to waiting time problems, a concept quietly discussed in population genetics. It asks, how long would it actually take for 2 coordinated mutations to appear and spread through a population? Not just one mutation, but 2 dependent on each other. The math. Tens of millions of years, just for 2. But many evolutionary changes require not 2, but hundreds of precisely timed mutations. More than time. More than random chance can realistically account for. And yet we're told the story continues upward, smoothly, inevitably. But the probabilities don't say inevitable. They say improbable. And not just improbable, but astronomically so. So what do we do with that? We say, well, we're here, so it must have happened. That's true, but it's not an explanation. It's a shrug. And science, good science, doesn't shrug at numbers. It listens. And what the numbers are quietly saying is this: the elegant machinery of life does not look like the product of random typing. It looks like something else. Perhaps an algorithm. Perhaps intention. Perhaps design. Let's be clear. This isn't an argument from ignorance. It's not, we don't know, therefore design. It's an argument from information, from complexity, from time and probability and limits. Because evolution by natural selection is not an infinite painter. It cannot try everything. It is bound by population size, mutation rates, lifespan, and generations. It cannot go anywhere. It can only go where math allows it. And sometimes, math does not allow it. Reason 9. The circular reasoning of adaptation. We've wandered through DNA, through consciousness, through the silence before life began. And now we turn to a softer, more curious question. Not about what evolution explains, but how it explains. Because while evolution is often praised for its elegance, for its ability to account for the diversity of life, there's something circular hidden in the storytelling. Something that feels less like science and more like assumption. Let's begin with a classic phrase. This trait exists because it helped the organism survive. It sounds reasonable. Adaptations help. Survival is rewarded. But what happens when we start asking, how do we know it helped the organism survive? The answer often is, because the organism survived. And just like that, the explanation folds back on itself. The trait exists because it conferred survival advantage. And we know it conferred survival advantage because it exists. It's a tidy loop, a self-sealing logic. But is it science? Or is it a story? Because science, at its best, makes testable predictions. It risks being wrong. It opens itself to challenge. But when every trait, no matter how strange, is explained after the fact by how useful it might have been, we leave the realm of testable science and step into the realm of just-so stories, like the ones told around campfires. Why does the giraffe have a long neck? To reach tall trees. Why do peacocks have such ornate feathers? To attract mates. Why do we cry when we're sad? To signal vulnerability. Each answer is neat, plausible, comforting. But what happens when we look closer? Take the giraffe. Its long neck helps it reach leaves. Yes, but giraffes also bend down to drink, exposing themselves to predators. They've evolved special blood pressure adaptations to avoid fainting when they do. So did the neck evolve for feeding? Or for mating displays? Or for thermoregulation? Or as a byproduct of something else entirely? The answer often changes. Not based on new data, but based on new narratives. The same happens with human behavior. Why do we blush? Why do we laugh? Why do we enjoy music? Evolutionary psychology offers explanations. Blushing helps maintain trust. Laughter evolved from playfighting. Music bonded early tribes, maybe, or maybe not, because for every behavior, we can invent a function. And once we invent it, we call it adaptive. And once it's adaptive, we call it evidence. And once it's evidence, we've proven the theory by assuming the theory. This is what philosopher Karl Popper warned against. A theory that explains everything. Explains nothing. Because if no observation could falsify it, it ceases to be science. It becomes a lens, a filter. A way of seeing that always affirms itself. Even anomalies get absorbed. The Cambrian explosion, rapid evolution, the absence of transitional fossils, poor preservation, the irreducible complexity of systems, co-option of parts with different functions. Each challenge has an answer, and the answer always points back to the theory. But what if just once we paused and said, we don't know, not to undermine science, but to honor it? Because science begins not with certainty, but with doubt. It begins not with narrative, but with curiosity. Let's look at wings. Birds fly. So do bats. So do insects. But their wings are not the same. They don't come from a common flying ancestor. So we call it convergent evolution, the idea that different organisms independently evolve similar traits. It happens with eyes, too. Complex camera-style eyes evolved in vertebrates, cephalopods, and even jellyfish. Did all of them stumble upon the same solution independently? Maybe. But again, the theory is protected. If two creatures share a trait, they either inherited it or evolved it separately. Either way, evolution wins. This is not to say evolution explains nothing. Of course it does, but perhaps it explains too much. And when an idea explains both success and failure, both presence and absence, both simplicity and complexity, we must ask, is it describing the world? Or interpreting it? Is it predicting outcomes? Or narrating them? And if it is narrating them, should we treat those stories as settled truth? Reason 10. The problem of functional complexity in biological systems. You see, evolution claims life is a story of accidents. Tiny, beneficial accidents, preserved by survival, stacked over time, building what we see today. But the more we learn about biology, the more that story begins to tremble. Not because of what we don't know, but because of what we do. Let's go to the cell. The cell isn't just a blob. It's a factory. A city. A system so complex that even Nobel laureates confess we're only beginning to understand its layers. Inside, machines move cargo along protein highways. RNA gets edited, checked, repaired. Molecular scissors cut at errors. Chaperone proteins fold others into shape. Membranes communicate with other membranes, sending signals like diplomats passing sealed notes. Every action is regulated. Every function connected. If even one part malfunctions, cells can die, or mutate, or turn cancerous. And yet, for billions of years, these microscopic miracles keep humming. Flawless? No, but undeniably intricate. You wouldn't look at a microchip and assume it grew on a tree. You wouldn't stare at a jet engine and say, what a lucky storm of parts. And yet we're asked to believe that molecular engines like ATP synthase, which spins like a rotary turbine, generating energy in every living cell, assembled itself without guidance, because evolution demands randomness. Not intention, not foresight, but everything about these systems feels intentional, like something that was built with a function in mind. We see the same signature across life. In insects that mimic leaves, not just in color, but in shape, texture, vein, pattern, and behavior. In migratory birds that navigate continents using magnetic fields. How did those magnets evolve before they were useful? In the monarch butterfly, whose caterpillar form digests milkweed, stores the toxins, and later emerges as a butterfly, still toxic, still magnificent. Each stage, egg, larva, pupa, adult, coded in advance. Not random, not reactive. Programmed. Now pause. In technology, when we see programming, we infer a programmer. When we see function, we infer design. It's not a leap. It's pattern recognition. And yet in biology, design is taboo. We're told it's not scientific, that it invokes untestable ideas. And yet, when we see a perfectly synchronized system, we call it a design flaw when it breaks. Funny, isn't it? We only say flaw if we first believed it had a function. Like the human eye. For decades, textbooks mocked it as poorly designed. The retina's backward wiring, the blind spot, the supposed inefficiencies. But as science advanced, we discovered that backward wiring helps filter noise. The blind spot is covered by brain processing. What was called a mistake was actually a marvel, and so the pattern repeats. What once looked like clumsy evolution reveals itself as quiet precision. This doesn't mean perfection. This doesn't mean paradise. Biology still breaks. Diseases still strike. But a broken watch is still evidence of a watchmaker. And a flawed system can still carry the fingerprints of design. Let's think deeper. Information. Where does it come from? DNA is not just chemistry, it's coding. It's not just structure, it's syntax, like language. And we've never observed information emerge from matter without an intelligent source. Never. If you found writing on a cave wall, you wouldn't assume erosion. If you saw music on a page, you wouldn't thank the wind. But DNA, we're told it built itself, meaning grammar, feedback loops, and all. Even though every system of coded communication we'd ever known came from mind. That's the echo design. Not a religious word, a scientific one. A word we use in engineering, in systems theory, in computer science, to describe intentional complexity that exceeds what randomness can realistically achieve. Does evolution explain some things? Yes. Microevolution. Absolutely. Antibiotic resistance. Clearly. Variation, adaptation, resilience. These are real, observable, testable. But macroevolution, the leap from bacteria to Beethoven, still stands on unobserved bridges. Reason 11. Darwin's own doubts in the limits of his theory. Charles Darwin. Tonight, we walk not in opposition to Darwin, but beside him. Not in protest, but in shared confusion. Because for all that he observed, and all that he proposed, Darwin, this quiet, brilliant, self-questioning soul, held doubts, deep ones. And on the origin of species, he does not speak as a man certain of everything. No, he writes like a man walking through fog, naming shapes as best he can, but always aware that something might be missing. Let's return to his own words. To suppose that the eye could have been formed by natural selection seems, I freely confess, absurd in the highest degree. He wrote that, not a skeptic, not a religious critic. Darwin, he went on to explain how, perhaps, it could have evolved, step by step, light sensitivity to basic lenses to advanced focus and adaptation. But the doubt remained, the wonder, the absurdity, and it didn't end with the eye. In a private letter, he confided something even deeper. The horrid doubt always arises whether the convictions of man's mind are of any value or at all trustworthy. Would anyone trust the convictions of a monkey's mind if there are any convictions in such a mind? Pause. Let those words drift through you. Darwin feared that if our thoughts, our logic, our reason, were merely products of survival, shaped not for truth but utility, then why should we trust them? If your brain evolved to help you run from tigers or find berries in the dark, why would it also help you grasp quantum mechanics, or imagine justice, or write poetry? This is not theology. This is philosophy, and Darwin knew it. He knew that to explain everything through evolution might one day undercut the very mind doing the explaining. So he doubted. Quietly, privately, and perhaps you felt it too. That tug, that breath at midnight. You read the diagrams. You nod through the lectures. You see the trees of ancestry, the branching charts. And yet, something inside you whispers, but what if that's not the whole story? That's not heresy. That's honesty. Because doubt is not the enemy of science. Doubt is the seed of science. Darwin's doubts gave us questions. Questions gave us exploration. And exploration gave us modern biology. But now, when doubt points back toward mystery, toward meaning, toward intelligence beyond mutation. We're told to hush. We're told the science is settled. But science, real science, never settles. It flows. It evolves. It wonders. Even Darwin, in his final years, softened toward mystery. He rejected the caricatures. He rejected blind, mechanical evolution devoid of awe. He still believed in natural selection, but he knew it didn't explain consciousness, or morality, or the origin of life, and he was okay not knowing. So why can't we be? Reason 12, the hard problem of consciousness. Now feel that quiet presence within you, not your heartbeat, not your breath, but something deeper, that part of you that is watching your breath, that knows you're lying in bed, that feels you are you. Consciousness, not the brain, not neurons, not circuits firing in darkness, but you. And here, dear listener, is where evolution begins to falter. Because while it speaks fluently about limbs and lungs, about feathers and fur, it stammers in the presence of awareness. Let's take a step back. The story of evolution tells us that life began in a puddle, a mix of chemicals sparked by lightning, which somehow began to replicate. From there, cells, tissues, creatures, minds, and eventually you. But somewhere along that climb from molecule to man, something emerged that molecules have never shown on their own. Subjective experience, not reflexes, not movement, but the inner world, pain, joy, curiosity, the taste of strawberries, the color blue, the feeling of being watched, the ache of nostalgia. None of these are chemicals. They are qualia, the textures of awareness. You don't just process light, you see it. You don't just react to sound. You hear music, and it moves you. Why? Evolution says the brain evolved to help us survive, to escape predators, to find mates, to solve problems. Fine. But why should problem-solving involve consciousness? A computer can play chess. A spider can weave webs. A tree can grow toward light. None of them are conscious as far as we know. So why do you feel heartbreak? Why do you fall in love with strangers in dreams? Why do you ponder your own death and feel something eternal watching back? These are not survival traits. They are mysteries, and evolution offers no clear path from non-experience to experience. No fossil or half-conscious being. No mutation that made pain suddenly hurt. No gene that made colors suddenly vivid. Neuroscientists can scan your brain and tell you what lights up when you're angry or afraid or dreaming. But they can't tell you why those lights result in you. They can't explain how gray matter produces beauty. This is known as the hard problem of consciousness. And it is the Everest of modern science. Even materialist philosophers, those who insist that only the physical exists, admit they cannot explain it. Some propose radical solutions. Panpsychism, the idea that all matter, even atoms, has some tiny form of experience. Others suggest consciousness is an illusion. But then, who's being fooled? And still others suggest it never evolved at all, because it can't. That it entered life as something other. Something beyond evolution, beyond biology, beyond the physical world. A gift, a spark, a soul. Now we tread gently here, because consciousness is intimate, sacred even. It is the one thing you know for certain. You doubt your memories, doubt your dreams, doubt this very video. We cannot doubt that you are experiencing something right now. And no story of natural selection, no theory of blind mutation, no equation of matter rearranged, has ever explained how molecules became a mind. So perhaps they didn't. Perhaps consciousness didn't emerge. Perhaps it was there first. The universe wasn't unconscious. slowly becoming aware. Perhaps it began aware and then built stars to light its path. Perhaps what evolution can't explain isn't a gap in evidence, but a signpost. Here, science meets mystery. And that's okay. Not everything needs to be solved to be real. Some things only need to be felt. Reason 13. The unexplained origin of language. Let your thoughts drift again, this time into something invisible. Not a cell or a fossil or a protein, but something made entirely of meaning. Language, that quiet miracle we used to think. To love, to remember, to wonder. You're hearing these words right now not just as sounds, but as ideas. And that is astonishing, because language isn't just noise. It's not a bird's cry or a cat's purr. It's not instinct. It's syntax, structure. Symbols arranged according to rules you didn't invent, yet you use effortlessly. By age 3, most children understand grammar. By 5, they can tell stories. By 10, they're weaving sarcasm, metaphor, and poetry into every sentence. But how? How did the human brain, this lump of neurons and blood, begin generating infinite meaning from finite symbols? Let's step back. Most animals communicate. Bees dance. Dolphins whistle. Primates grunt and gesture. But human language isn't just communication. It's composition. We don't just point at food or danger. We speak in conditionals. If I had known you were coming, I would have baked a cake. Try teaching that to a chimpanzee. Linguist Noam Chomsky called this ability unbounded. Because with just a few words and some rules, we can generate sentences no one has ever said before, and yet they still make perfect sense. Like, if clouds dream, do they imagine oceans? Or tomorrow's memories haven't been written yet. That's language. It reaches forward and backward through time. It shapes thought. And it does something else too. It changes reality. With words, we make promises. We sign contracts. We say, I love you. We say, I forgive you. We name our children and we write down our dreams. No other species does this. So we ask, how did it begin? Evolution suggests a gradual pathway. That vocalizations became more complex. That gestures gained meaning. That brain regions like Broca's and Wernicke's areas expanded with time. But here's the puzzle. Language only works if everyone already agrees on the system. Words are meaningless unless a community assigns meaning to them, together. A child can't invent a language alone. It must be shared, passed on, woven into culture. So how did the first speakers speak? How did the first listeners listen? How did a structure as complex as grammar emerge, if it only functions when already complete? Let's get specific. To speak, you need a brain that can structure abstract ideas, a vocal tract fine-tuned to produce a range of sounds, lungs and diaphragms to control breath, hearing sophisticated enough to parse phonemes, a social structure that rewards symbolic communication, a memory system robust enough to store thousands of word meanings. And most mysteriously, you need a desire to express the invisible. Where did that come from? Language has no fossil record. We can't dig up words, but we do find clues in cave paintings, in burial sites, in ancient myths passed from mouth to ear. And when we look back into prehistory, it's a sudden burst. A great leap forward, some call it. Roughly 50,000 years ago, give or take a few thousand, something stirred in the human mind. Something that had never stirred before, and the world was never the same again. Not slowly, not incrementally, but all at once. It's as if the human mind lit up overnight. Evolution alone doesn't explain this leap, at least not fully, because no half language is useful. Grammar doesn't evolve by accident. And so, we wonder, did language evolve, or did it arrive? Some say it was a mutation, a lucky accident. Others say it was cultural, that once the first few spoke, others followed. But even that begs the question, how did the first ones begin? The philosopher Thomas Nagel once asked, is there something it is like to be a bat? In other words, does a bat experience consciousness? Now take that question and apply it to early hominins. What was it like to be the first creature to name the moon? To describe a dream? To say I am? Because I is a word, a sound that splits the universe into self and other. And that's what language does. It turns chaos into categories. It builds bridges across isolation. It makes thought visible. No other system in the body does that. Not digestion, not circulation, only speech. And speech isn't made of atoms. It's made of meaning. Meaning isn't random. It's not survival. It's not utility. It's intention. And intention is personal. Now we don't claim to know where language came from, but we invite the question, is it the result of mutation or the signature of mind? Was it formed by evolution or framed by something beyond it? Maybe language isn't just a tool. Maybe it's a clue, a fingerprint of something higher, not shouted, that's softly spoken. Reason 14, the great leap forward in human creativity. We've wandered through DNA and design, through cells and spirals, through language and consciousness. But now, let's step back, way back, to the moment in history when everything changed. It's called the Great Leap Forward, or sometimes the human revolution, and no one knows exactly why. It happened. But it did. Roughly 50,000 years ago, give or take a few thousand. Something stirred in the human mind. Something that had never stirred before, and the world was never the same again. Before this leap, our ancestors made tools, simple ones. They hunted, they gathered, they survived. But their lives were largely repetitive, their cultures slow to change. Then, suddenly, like a flame catching dry grass, they painted, they carved. They sang. They buried their dead with flowers. They wore shells as jewelry. They built traps for animals. They crafted flutes from bone. And above all, they began to imagine. Not just react, not just survive, but imagine. They painted animals they'd never tamed. They told stories of spirits and stars. They dreamed of gods and life after death. This was something new. And the question is, why? Why did the human brain, which had existed in roughly the same form for tens of thousands of years, suddenly begin to dream? Evolution has its explanations. Some suggest a genetic mutation, a tweak in brain wiring that sparked abstract thought. Others point to a critical mass of language. That once communication reached a certain level, culture followed. Still others say it was social pressure, that art and ritual emerged to form tighter tribes and better cooperation. These are ideas. They're thoughtful, but they're also incomplete, because what changed wasn't just survival strategy, it was conscious creativity. It was self-awareness projected onto the world. It was meaning etched into stone. Let's visit a cave, somewhere in France, or Spain, or Indonesia. Inside, painted on the stone walls, you'll see animals. Bison, horses, lions, drawn with exquisite care. Not crude, not primitive. Elegant. They used perspective, shading, natural contours of the cave walls to give the illusion of motion. Some of these paintings are older than the pyramids, by tens of thousands of years. And yet they speak. They whisper of minds that thought deeply, that told stories, that cared about beauty. And the strangest part, their brains were no different from ours. They were us. So what happened? Why did culture erupt like a volcano after so many years of silence? Why did human creativity wait, and then suddenly overflow? Some say it was a tipping point, but tipping points require something to tip. And for hundreds of thousands of years, nothing tipped. Then, everything did. Some scientists have even admitted this leap looks less like gradual evolution and more like a software upgrade, an update to human cognition that arrived not step by step, but all at once. But evolution doesn't do software updates. It doesn't install imagination overnight, and so the mystery lingers. Could it be that the human mind was never meant to evolve slowly? Could it be that it was lit like a candle? Some traditions speak of the soul as something breathed, given, awakened, and in a purely scientific sense, we see the flicker, the emergence of theory of mind, the ability to think about what others are thinking, to lie, to tell stories, to laugh at things that aren't real. That's not just intelligence. That's interiority, and it raises questions evolution can't fully answer. Why do we mourn the dead? Why do we write songs? Why do we gaze at stars and wonder what they mean? These are not survival traits. They are human traits, and they arrive suddenly. Too suddenly for comfort. Let's pause now and remember the Neanderthals, another branch of human ancestry. Strong, clever, capable. For thousands of years, they lived alongside early Homo sapiens. Then, mysteriously, they disappeared. Extinct, but not wiped out by war or famine. They simply faded. Some believe they were outcompeted, not by weapons, but by imagination. Homo sapiens sang around fires, shared myths, passed stories through generations. Neanderthals did not, and perhaps that made all the difference. So we ask again, softly, where did that spark come from? Was it a genetic fluke? A chance combination of mental abilities? Or was it something more? Was it the awakening of something sacred? Something that evolution alone cannot fully explain. The leap forward wasn't just a leap in technology. It was a leap in meaning, in purpose, in soul. And maybe, just maybe, the fact that it still puzzles scientists is a clue that it didn't come from the bottom up, but from the top down. Reason 15, the problem of irreducible complexity. Inside your body right now, quietly, without you asking, microscopic machines are spinning, folding, snapping into action. Molecular gears, protein switches, tiny motors and conveyor belts, not metaphorical ones. Literal. Let's meet one. It's called the bacterial flagellum. You might never have heard of it, and yet this tiny wonder is one of the most debated little motors in all of biology. Picture this. A tiny tail like a corkscrew, protruding from a microscopic bacterium. It spins rapidly, clockwise, counterclockwise. It can start, stop, reverse, just like an outboard motor. Except it's not built by human hands. It builds itself from protein parts, and it works in water like a propeller does in air. Now this motor isn't just pretty. It's precise. It has a rotor, stator, bushings, a drive shaft, a U-joint, and even a clutch. It spins at 100,000 RPM and can stop in a quarter turn. All of this inside a single cell. And evolution tells us this motor built itself slowly over generations, piece by random piece. But here's the thing. Remove one part, just one protein, just one gear, and the whole machine stops working. It's what biochemist Michael B. famously called irreducible complexity. A mousetrap, he said, doesn't work with only a spring. You need the base, the hammer, the catch. Take away any one part and you have not a less effective mousetrap, no trap at all. The same with the flagellum. The same with dozens of biological systems. Now, critics argue, maybe those parts once had different functions. Maybe they evolved independently and came together later. That's a possibility, but a precarious one. Because building a machine is not the same as scattering parts in a drawer. You don't get an engine by tossing bolts and belts into a box and hoping a tornado assembles them. You need a blueprint and order and purpose. And in the case of the flagellum, you need more than 40 proteins, each encoded in DNA. Each synthesized at the right time, each folded into the right shape, each transported to the right location in the right sequence, and then somehow assembled into a spinning, self-healing, self-constructing nanomotor, all by accident. Now, this isn't just about the flagellum. Let's turn our attention to another system, blood clotting. A marvel, really. When you get a cut, your body leaps into action. Platelets rush to the site. Proteins cascade in a perfect sequence. Clots form, just enough to stop bleeding, but not so much that they block your veins. It's not a single step. It's not even 10. It's over 20 chemical reactions, each triggering the next like dominoes. Miss one step and the blood doesn't clot. Or worse, it clots too much. In both cases, danger. Hemophilia or stroke. How do such systems evolve gradually? If Step 4 doesn't help until Step 9 exists, why would natural selection preserve it? Nature has no foresight, no grand planner, no someday to aim for, only what works now. And half a blood clotting system doesn't work. Same for the human eye. Now, many will say, the eye is often used by creationists, but we've explained its evolution. And yes, there are diagrams showing how light-sensitive spots could slowly deepen into pits, then into lenses, then into full eyes. But diagrams are not mechanisms. And the retina, it's not just a cup, it's a living electrical sensor. Light hits photoreceptor cells, rods, and cones. Signals pass through bipolar cells, ganglion cells along the optic nerve to the visual cortex. All of this happens in milliseconds. And here's a curious fact, the retina is wired backward. Light passes through layers of nerve cells before hitting the photoreceptors. An odd design, or a precise one. Even more strangely, the rods and cones renew themselves constantly. The outer segments slow off and regenerate daily. Why? Because light damages them, and so the eye anticipates this damage and builds in a maintenance system. Ask yourself, does this feel like an accident? Or like machinery built not slowly, but all at once? Now, let's return to the core idea of evolution. That complex systems arise through many small, survivable steps. Each mutation must offer some benefit, even a tiny one, to be kept. But what if the benefit only appears once the whole system is present? Natural selection cannot select what does not yet function. And so we ask, not to disprove, but to wonder, is it possible that some of life's systems are not slowly sculpted, but suddenly assembled? Not evolved, but engineered? Again, this isn't about religion. It's not about doctrine. It's about design. The quiet possibility that some systems look too coordinated to be coincidental. Reason 16. The mathematical patterns in nature. And tonight, let's wander together into one of the most surprising rhythms of all, the mathematics of life. You see, when we talk about evolution, we're often told that nature is messy. That life is the result of countless mistakes, accidents preserved by survival, randomness sifted by time. But have you ever looked closely, truly closely, at a sunflower? Each seed in its golden face follows the spiral. A perfect spiral. Two, actually. One clockwise, one counterclockwise, and the number of spirals in each direction. Almost always a Fibonacci number. 34 spirals this way, 55 the other, or sometimes 89 and 144. Numbers from a sequence that appears in nature over and over again. 1, 1, 2, 3, 5, 8, 13. Each number is the sum of the two before it. Simple, yet strangely profound. This same sequence appears in pine cones, in pineapples, in the whorls of Romanesco broccoli, in the curve of a nautilus shell. But why? If life is random, why does it keep producing this kind of beauty, this kind of order? Spirals, ratios, symmetry. Why is the golden ratio, approximately 1,618, found in the proportions of leaves, pills, even galaxies? Evolution tells us these patterns exist because they help, because they're efficient, because spiral packing maximizes space. And yes, there's truth in that. Mathematically, spiral growth avoids overlap, maximizes sunlight, minimizes competition. But what about the origin of the pattern itself? Efficiency is the result, but what is the cause? A sunflower doesn't know math, and yet it grows with a precision that would put engineers to shame. Let's move from flowers to wings. Butterfly wings, delicate, colored, and astonishingly geometric. Zoom in close enough, and you'll find the colors are not made from pigment, but from microscopic structures, nanostructures, tiny scales arranged in repeating lattices that interfere with light waves to produce iridescence. It's called structural coloration, and it's not simple, not something produced by chance bumps and folds. It's architecture, at the nanoscale. Peacock feathers do the same. So do beetle shells and the wings of morpho butterflies. These are photonic crystals, and we still don't fully understand how they self-assemble, or how genes encode not just color, but interference patterns. Now pause here. Imagine evolution selecting for iridescence by randomly mutating genes until light just happens to bounce at the right frequency. Could it happen? Possibly. But does it feel likely? Or does it feel choreographed? Like a secret math humming underneath nature's skin. Even in DNA itself, mathematics hides. The four chemical bases, at T, C, and G, pair in predictable ways. Always A with T, C with G. They form a double helix, a spiral staircase. And that helix is not arbitrary. Its pitch, twist, and rise follow consistent proportions. The diameter, about 2 nanometers. The twist, 10.5 base pairs per turn. Where did that precision come from? When you fold a protein, which happens every second in your body, it doesn't just crumple like a piece of paper. It folds according to physics, to charge, polarity, hydrophobicity, to angles and balances so delicate we still can't predict them perfectly with computers. And yet your body folds billions of them flawlessly, each one like origami designed by atoms. Mathematics, masquerading as biology. Let's look at snowflakes. Not alive, but instructive. Each snowflake forms from water molecules, random motion in clouds, and yet no two are exactly alike. Still, they're all six-pointed. Hexagons. Symmetrical. Why? Because the hydrogen bonds in water form 120-degree angles. They obey geometric rules. Rules that create beauty without anyone intending it. So, we must ask, where do the rules come from? Why does nature seem to prefer elegance? Is it all just physics? A lucky convergence of forces and constraints? Or is there something deeper? Something encoded not just in DNA, but in the varied fabric of the universe? Consider this quote from physicist Paul Davies. The impression of design is overwhelming. Life seems almost too ingenious to be an accident. Now, to be clear, this isn't about rejecting evolution entirely. Evolution describes many things beautifully. It explains how traits spread, how variation works, how populations adapt. But it struggles to explain why the raw material, life's building blocks, are already humming with symmetry, geometry, and code. Evolution selects, but it does not write the rules of math. So we ask softly, where did those rules come from? Where did the numbers hide before the first sunflower turned to face the light? And why did they appear again and again like footprints in wet soil? As if something walked here and left its logic behind. Reason 17. The problem of consciousness and subjective experience. Something that doesn't show up on X-rays. Something you can't put under a microscope. And yet, it's the only reason you're even hearing these words right now. Consciousness. That quiet hum behind your thoughts. The gentle presence you call I, the observer behind your eyes. You've never seen it. You can't measure it directly. But you know it's there because you are there. So what does evolution say about this invisible flame? In its simplest form, the theory tells us that consciousness evolved, like anything else, slowly, accidentally, as a helpful tool. A useful trick for survival. A way to track pain. To plan. To anticipate. To flee before the lion pounces. And yes, that's part of the story. Consciousness gives us an edge. Awareness helps. But here's where the questions begin to whisper. Because your brain is made of matter. Cells. Synapses. Neurons that fire in electrical patterns. You could map them. Draw them. Trace every signal from one to the next. But in all that matter, where's the experience? Where is the redness of red? The sweetness of honey? The ache of longing? The warmth of love? You'd scan every neuron in your mind and never find your favorite memory. You dissect every cell and still not touch a thought. This is what philosophers call the hard problem of consciousness. Not how the brain reacts to stimuli, but why there's any experience at all. Why it feels like something to be you, because it doesn't have to. A robot can process data. A computer can make decisions. But a computer doesn't dream. It doesn't feel lonely. It doesn't wonder who it is. It doesn't lie awake and ask, why am I here? Yet you do. That's the paradox. We're told that consciousness is an emergent property, a side effect of complexity. That if you just wire up enough neurons, the lights somehow turn on. But emergence doesn't explain why. It's like saying a painting emerges from brushstrokes, but never asking who chose the colors. Some scientists argue that consciousness is an illusion, a trick of the brain, a hallucination we mistake for self. But who exactly is being tricked? Who's watching the illusion? Who's inside behind the curtain asking the question? Evolution is good at explaining behavior, but it struggles to explain being. Let's return to biology for a moment. The human brain is the most complex structure we've ever discovered. Roughly 86 billion neurons, each one connecting to up to 10,000 others. That's more connections than there are stars in the galaxy, and all of it inside your skull. Running on sugar and sleep, it's awe-inspiring. But it's still structure. A computer is also complex. But no matter how many transistors you add, it doesn't wake up. So again, we ask gently, is there more to consciousness than chemistry? Let's ask a simple question. Where does thought begin? Not just the brain waves that follow a decision, but the will behind it. You decide to move your hand. You decide to speak. You choose to listen to this video rather than the billions of other things you could be doing. What is the source of that choice? If it's just neurons, then where is freedom? And if everything is determined by matter, then who are you really? This brings us to something called qualia, the individual instances of subjective experience. The blueness of blue, the taste of strawberries, the melancholy of a rainy Sunday. These things are real, but they are not measurable. They exist inside you in space no scalpel can reach. And yet, somehow they evolved. How? At what point did atoms become aware? At what point did chemicals start to feel? When did a system of cells begin to say I? If we say it was gradual, what does a half-conscious being feel like? When do the lights begin to flicker on? If evolution is about survival, why would consciousness evolve at all? Pain can exist without awareness. Reflexes don't require thought. Digestion doesn't need dreams. So why dream? Why imagine? Why write poetry or hum a song you'll never share? Evolution explains function, but consciousness doesn't always serve a function. Sometimes it simply is. There are those who propose that consciousness is not the result of matter, but the source of it, that it's not a product of the brain, but a fundamental part of reality, like space, or time, or gravity. Some physicists wonder if consciousness is woven into the universe, not a late arrival, but a starting point. Like a flame lighting the first stars, we're not here to prove that. We're only here to wonder, because when you hold a newborn child and they look up at you, something passes between you, something beyond biology, beyond survival, a connection, a recognition, and in that moment, you know there's more to us than cells. There's more to you than neurons. There's a you, and you are awake. Reason 18, the uniqueness of human language. Let your thoughts drift again, this time into something invisible, not a cell or a fossil or a protein, but something made entirely of meaning. Language, that quiet miracle we used to think. To love, to remember, to wonder. You're hearing these words right now, not just as sounds, but as ideas. And that is astonishing, because language isn't just noise. It's not a bird's cry or a cat's purr. It's not instinct. It's syntax, structure. Symbols arranged according to rules you didn't invent, yet you used effortlessly. By age 3, most children understand grammar. By 5, they can tell stories. By 10, they're weaving sarcasm, metaphor, and poetry into every sentence. But how? How did the human brain, this lump of neurons and blood, begin generating infinite meaning from finite symbols? Let's step back. Most animals communicate. Bees dance. Dolphins whistle. Primates grunt and gesture. But human language isn't just communication. It's composition. We don't just point at food or danger. We speak in conditionals. If I had known you were coming, I would have baked a cake. Try teaching that to a chimpanzee. Linguist Noam Chomsky called this ability unbounded, because with just a few words and some rules, we can generate sentences no one has ever said before, and yet they still make perfect sense. Like, if clouds dream, do they imagine oceans? Or tomorrow's memories haven't been written yet. That's language. It reaches forward and backward through time. It shapes thought. And it does something else too. It changes reality. With words, we make promises. We sign contracts. We say, I love you. We say, I forgive you. We name our children, and we write down our dreams. No other species does this. So we ask, how did it begin? Evolution suggests a gradual pathway. That vocalizations became more complex. That gestures gained meaning. That brain regions like Broca's and Wernicke's areas expanded with time. But here's the puzzle. Language only works if everyone already agrees on the system. Words are meaningless unless a community assigns meaning to them, together. A child can't invent a language alone. It must be shared, passed on, woven into culture. So how did the first speakers speak? How did the first listeners listen? How did a structure as complex as grammar emerge, if it only functions when already complete? Let's get specific. To speak, you need a brain that can structure abstract ideas, a vocal tract fine-tuned to produce a range of sounds, lungs and diaphragms to control breath, hearing sophisticated enough to parse phonemes, a social structure that rewards symbolic communication, a memory system robust enough to store thousands of word meanings. And most mysteriously, you need a desire to express the invisible. Where did that come from? Language has no fossil record. We can't dig up words, but we do find clues in cave paintings and burial sites, in ancient myths passed from mouth to ear. And when we look back into prehistory, it is a sudden burst, a great leap forward, some call it. Roughly 50,000 years ago, give or take a few thousand, something stirred in the human mind, something that had never stirred before, and the world was never the same again. Not slowly, not incrementally, but all at once. It's as if the human mind lit up overnight. Evolution alone doesn't explain this leap, at least not fully, because no half-language is useful. Grammar doesn't evolve by accident. And so we wonder, did language evolve, or did it arrive? Some say it was a mutation, a lucky accident. Others say it was cultural, that once the first few spoke, others followed. But even that begs the question, how did the first ones begin? The philosopher Thomas Nagel once asked, is there something it is like to be a bat? In other words, does a bat experience consciousness? Now take that question and apply it to early hominins. What was it like to be the first creature to name the moon? To describe a dream? To say I am? Because I is a word, a sound that splits the universe into self and other. And that's what language does. It turns chaos into categories. It builds bridges across isolation. It makes thought visible. No other system in the body does that. Not digestion. Not circulation. Only speech. And speech isn't made of atoms. It's made of meaning. Meaning isn't random. It's not survival. It's not utility. It's intention. And intention is personal. Now, we don't claim to know where language came from, but we invite the question, is it the result of mutation, or the signature of mind? Was it formed by evolution, or framed by something beyond it? Maybe language isn't just a tool. Maybe it's a clue, a fingerprint of something higher, not shouted, but softly spoken. Reason 19, the problem of information origin. Let's think deeper. Information. Where does it come from? DNA is not just chemistry. It's coding. It's not just structure. It's syntax, like language. And we've never observed information emerge from matter without an intelligent source. Never. If you found writing on a cave wall, you wouldn't assume erosion. If you saw music on a page, you wouldn't think the wind. But DNA. We're told it built itself, meaning, grammar, feedback loops and all, even though every system of coded communication we'd ever known came from mind. That's the echo design. Not a religious word, a scientific one. A word we use in engineering, in systems theory, in computer science, to describe intentional complexity that exceeds what randomness can realistically achieve. Does evolution explain some things? Yes. Microevolution. Absolutely. Antibiotic resistance. Clearly. Variation, adaptation, resilience. These are real, observable, testable. But macroevolution, the leap from bacteria to Beethoven, still stands on unobserved bridges. Reason 20, the limits of natural selection. You see, evolution claims life is a story of accidents. Tiny, beneficial accidents, preserved by survival, stack over time, building what we see today. But the more we learn about biology, the more that story begins to tremble. Not because of what we don't know, but because of what we do. Let's go to the cell. The cell isn't just a blob. It's a factory, a city, a system so complex that even Nobel laureates confess we're only beginning to understand its layers. Inside, machines move cargo along protein highways. RNA gets edited, checked, repaired. Molecular scissors cut errors. Chaperone proteins fold others into shape. Membranes communicate with other membranes, sending signals like diplomats passing sealed notes. Every action is regulated, every function connected. If even one part malfunctions, cells can die, or mutate, or turn cancerous. And yet, for billions of years, these microscopic miracles keep humming. Flawless? No, but undeniably intricate. You wouldn't look at a microchip and assume it grew on a tree. You wouldn't stare at a jet engine and say, "What a lucky storm of parts." And yet we are asked to believe that molecular engines like ATP synthase, which spins like a rotary turbine, generating energy in every living cell, assembled itself without guidance, because evolution demands randomness. Not intention, not foresight, but everything about these systems feels intentional, like something that was built with a function in mind. We see the same signature across life, in insects that mimic leaves, not just in color, but in shape, texture, vein pattern, and behavior. In migratory birds that navigate continents using magnetic fields. How did those magnets evolve before they were useful? In the monarch butterfly, whose caterpillar form digests milkweed, stores the toxins, and later emerges as a butterfly, still toxic, still magnificent. Each stage, egg, larva, pupa, adult, coded in advance. Not random, not reactive. Programmed, now pause. In technology, when we see programming, we infer a programmer. When we see function, we infer design. It's not a leap, it's pattern recognition. And yet in biology, design is taboo. We're told it's not scientific, that it invokes untestable ideas. And yet, when we see a perfectly synchronized system, we call it a design flaw when it breaks. Funny, isn't it? We only say flaw if we first believed it had a function, like the human eye. For decades, textbooks mocked it as poorly designed, the retina's backward wiring, the blind spot, the supposed inefficiencies. But as science advanced, we discovered that backward wiring helps filter noise. The blind spot is covered by brain processing. What was called a mistake was actually the marvel. And so the pattern repeats. What once looked like clumsy evolution reveals itself as quiet precision. This doesn't mean perfection. This doesn't mean paradise. Biology still breaks. Diseases still strike. But a broken watch is still evidence of a watchmaker. A flawed system can still carry the fingerprints of design. Let's think deeper. Information. Where does it come from? DNA is not just chemistry. It's coding. It's not just structure. It's syntax. Like language, and we've never observed information emerge from matter without an intelligent source. Never. If you found writing on a cave wall, you wouldn't assume erosion. If you saw music on a page, you wouldn't thank the wind. But DNA, we're told it built itself, meaning, grammar, feedback loops, and all. Even though every system of coded communication we've ever known came from mind. That's the echo design. Not a religious word, a scientific one. A word we use in engineering, in systems theory, in computer science, to describe intentional complexity that exceeds what randomness can realistically achieve. Does evolution explain some things? Yes, microevolution. Absolutely. Antibiotic resistance. Clearly. Variation, adaptation, resilience. These are real, observable, testable. But macroevolution, the leap from bacteria to Beethoven, still stands on unobserved bridges. Reason 21. The problem of the origin of life. The first cell, evolution begins with life, but doesn't explain where the first cell came from. Even the simplest bacterium requires over 250 harmoniously working proteins. A cell wall, DNA copying systems, energy conversion, and a vast instruction manual. If any part is missing, life fails. How did this complex system assemble randomly in a primordial soup? Protein folding. Proteins need precise 3D shapes to function. A single wrong fold renders them useless. How did the first correct folds emerge by chance? DNA and enzymes paradox. DNA needs enzymes to build itself, but enzymes are built using DNA. This chicken and egg problem remains unsolved. Miller-Urey experiment limitations. While the Miller-Urey experiment produced amino acids, these are merely ingredients, not life. Decades of research have failed to produce life for non-life in labs, even with modern technology. Time is a non-solution. The argument of given enough time is insufficient. Time doesn't solve complexity. It magnifies entropy. Life, even at its simplest, is an intricate city, not a random puddle. Information origin. DNA is a language, a code. Information theory suggests information comes from intelligence, not chemistry or chance. Codes don't write themselves. Languages don't emerge from noise. Panspermia as an admission. Nobel laureate Francis Crick's suggestion of panspermia, life seeded from space, implies life's origin on Earth is too unlikely to be random, moving the problem rather than solving it. Reason 22. The anthropic principle and fine-tuning of the universe. Perfect calibration for life. The universe appears precisely calibrated for life. Slight variations in fundamental constants, gravity, electromagnetism, proton mass, expansion rate, would render life impossible. Carbon's precision. Carbon, essential for life, exists due to eerily precise nuclear resonance levels in stars. Without this, no carbon, no biology. Water's balance. Water, the solvent of life, requires a perfect balance of oxygen and hydrogen bonding. The anthropic illusion versus multiverse. Theories like the anthropic illusion, we are here to observe it, or the multiverse, infinite universes. We are in the one that allows life, are philosophical arguments, not scientific models with empirical evidence. They attempt to explain away the fine-tuning rather than addressing its implications. Reason 23. The origin of morality. Beyond survival. Evolution suggests morality evolved for survival, for instance, tribal cohesion. However, many moral acts, self-sacrifice, risking life for truth, are inefficient for survival, suggesting a deeper source than mere biological imperative. Innate moral compass. The universal recognition of fundamental moral truths. Murder is wrong, kindness is good, across diverse cultures, suggests an innate moral compass, not a chaotic, randomly evolved system. DNA and values. The document questions if DNA, which builds bodies and brains, also subtly encodes values, hinting at a design or intent beyond random evolution. Reason 24. The information in DNA. Language from chaos? DNA is a complex language code, syntax, grammar, error correction. The document argues that language and code do not arise from chaos or random mutations. They require a speaker or coder. Complexity of genome. The human genome contains more organized information than the Encyclopedia Britannica, and its precise reading, transcription, and execution by molecular machines defy accidental emergence. Protein folding precision. Proteins must fold into exact shapes to function. Even minor errors lead to collapse and disease. The perfect folding of billions of proteins daily suggests intentional design, not random chance. Error-correcting codes. The discovery of error-correcting codes in genetic material, similar to those in advanced computer systems, implies a design to preserve the message for corruption. Reason 25. The missing link in human evolution. Lack of smooth transitions. While some hominin fossils exist, they don't form a smooth, continuous evolutionary ladder from ape to human. The record shows scattered pieces, overlapping timelines, and unexplained jumps. Punctuated equilibrium. The concept of punctuated equilibrium, species appearing suddenly, not gradually, challenges the traditional view of slow, incremental evolution. Reason 41. The irreducible complexity of life. Imagine a mousetrap. It has several parts: a base, a spring, a hammer, a catch, and a holding bar. If you remove even one of these parts, the mousetrap ceases to function. It cannot catch mice. This concept, known as irreducible complexity, suggests that certain biological systems are so intricate that they could not have evolved gradually through natural selection. Each component is essential for the system to work, implying that they must have appeared simultaneously and fully formed. How could a system that requires all its parts to be present from the beginning evolve step by step? This poses a significant challenge to the gradualistic view of evolution, suggesting that some biological structures are simply too complex to have arisen through a series of small, incremental changes. Reason 42. The problem of information origin. DNA is often described as the blueprint of life, containing vast amounts of complex, specified information. This information dictates everything from the color of your eyes to the intricate processes within your cells. The question then arises, where did this information come from? Evolution proposes that life arose from non-living matter through natural processes. However, the origin of complex, specified information, such as that found in DNA, is not adequately explained by random mutations and natural selection. Information, in our experience, always originates from an intelligent source. The idea that such highly organized and functional information could arise purely by chance, without any guiding intelligence, remains a profound mystery and a significant hurdle for evolutionary theory. Reason 43. The lack of transitional fossils. If evolution occurred gradually, as proposed, the fossil record should be teeming with transitional forms, creatures that show intermediate stages between different species. For example, we should find countless fossils showing the slow, step-by-step transformation of a reptile into a bird or a land mammal into a whale. However, the fossil record is characterized by sudden appearances of fully formed species, with significant gaps between major groups. While some argue that these gaps are due to the incompleteness of the fossil record, the consistent absence of clear, undisputed transitional series for many major evolutionary transitions remains a persistent problem. The fossil record, instead of a smooth, continuous progression, often presents a series of abrupt appearances, challenging the very notion of gradual evolution. Reason 44. The enigma of consciousness. Consciousness, the subjective experience of being aware, thinking, and feeling, remains one of the most profound mysteries in science. How could a collection of physical neurons and chemical reactions in the brain give rise to something as intangible and complex as consciousness? Evolutionary theory, which primarily focuses on physical survival and reproduction, struggles to adequately explain the emergence of consciousness. While some argue it's an emergent property of complex brains, this doesn't fully address the qualitative leap from non-conscious matter to subjective experience. The existence of consciousness, with its capacity for self-awareness, abstract thought, and moral reasoning, seems to transcend purely material explanations, suggesting a dimension beyond the reach of evolutionary mechanisms. Reason 45. The fine-tuning of the universe. The universe we inhabit appears to be incredibly fine-tuned for the existence of life. From the precise values of fundamental physical constants, like the strength of gravity and the electromagnetic force, to the specific properties of water and carbon, countless parameters seem to be perfectly calibrated to allow for the formation of stars, planets, and ultimately, life. Even a slight deviation in any of these values would render the universe inhospitable. While some attribute this to mere chance or the existence of a multiverse, the sheer improbability of such precise fine-tuning through random processes alone is staggering. This remarkable cosmic precision points towards an underlying design or purpose, a concept that stands in stark contrast to a purely undirected evolutionary process. Reason 46. The problem of altruism. Altruism, the selfless concern for the well-being of others, presents a significant challenge to evolutionary theory, which often emphasizes individual survival and the propagation of one's own genes. Why would an organism sacrifice its own resources, time, or even life for another, especially if that other is not a direct relative? While concepts like kin selection and reciprocal altruism attempt to explain some forms of cooperative behavior, they often fall short in accounting for truly selfless acts, particularly those extended to non-relatives or even across species. The existence of genuine altruism, which seems to defy the strict logic of genetic self-interest, suggests the deeper, non-evolutionary dimension to human and animal behavior. Reason 47. The origin of morality. Where does our sense of right and wrong come from? Morality, with its universal principles of justice, fairness, and compassion, is a uniquely human trait. Evolutionary explanations often attempt to ground morality in social contracts or adaptive behaviors that promote group cohesion and survival. However, this utilitarian view struggles to explain the inherent, often absolute, nature of moral imperatives. Why do we feel a deep sense of injustice when we witness suffering, even if it doesn't directly impact our survival? The existence of an innate moral compass, which often transcends purely pragmatic considerations, suggests the source beyond the realm of natural selection, pointing towards a transcendent foundation for ethical behavior. Reason 48. The uniqueness of human language. Human language is an extraordinarily complex system, far beyond the communication methods observed in any other species. Its capacity for abstract thought, symbolism, grammar, and the creation of infinite new sentences from a finite set of words is unparalleled. While some evolutionary theories propose a gradual development of language from simpler animal calls, this doesn't fully account for the qualitative leap in complexity and cognitive ability required for true human language. The intricate structure of syntax, the ability to convey complex ideas, and the capacity for self-reflection through language seem to point to a unique, non-gradual origin, suggesting a design that transcends purely evolutionary pressures. Reason 49. The persistence of religious belief. Despite scientific advancements and the rise of secularism, religious belief remains a pervasive and enduring aspect of human culture across the globe. Evolutionary explanations often attempt to reduce religion to an adaptive byproduct, a coping mechanism, or a social construct that promotes group cohesion. However, this reductionist view struggles to explain the profound spiritual experiences, the deep sense of meaning, and the transcendent aspirations that characterize religious faith. The universal human yearning for something beyond the material, the widespread belief in a higher power, and the enduring power of spiritual traditions suggests a fundamental aspect of human nature that cannot be fully explained by purely evolutionary or socio-biological factors. Reason 50. The problem of irreducible information. Building upon the concept of irreducible complexity, the idea of irreducible information posits that certain biological systems contain information that cannot be reduced to simpler, non-functional parts. Just as a complex computer program requires all its lines of code to function, certain biological processes, like DNA replication or protein synthesis, involve a cascade of precisely coordinated steps, each dependent on the others. If any part of this informational sequence is missing or incorrect, the entire system fails. The origin of such highly organized and functionally specific information, which seems to defy purely random generation, remains a significant challenge for evolutionary theory, suggesting an intelligent source for the complex informational architecture of life. Reason 51. The enigma of quantum mechanics and consciousness. We've explored consciousness as a hard problem, but let's delve deeper into its potential connection with the varied fabric of reality. Quantum mechanics. At the subatomic level, particles behave in ways that defy classical intuition. They can exist in multiple states simultaneously, superposition, and become entangled, instantly influencing each other regardless of distance. The act of observation or measurement seems to collapse these quantum possibilities into a single reality. This raises a profound question. Is consciousness in some way involved in this collapse? Some physicists, like Eugene Wigner and Roger Penrose, have speculated that consciousness is not merely an emergent property of the brain, but a fundamental aspect of the universe, perhaps even playing a role in shaping reality at the quantum level. If this is true, it suggests a universe far more interconnected and mind-dependent than purely materialistic views allow. Evolution, grounded in classical physics, struggles to account for a consciousness that might be intertwined with quantum phenomena, hinting at a deeper, non-materialistic foundation for our awareness. The very act of observing the universe seems to require a conscious observer, creating a circularity that challenges purely physical explanations for existence. Reason 52. The implausibility of spontaneous generation of complex information systems. We've touched upon DNA as information, but let's expand on the sheer improbability of complex information systems arising spontaneously. Consider a modern computer operating system. It's a vast, intricate network of code, algorithms, and protocols, all designed to work together seamlessly. No one would suggest that such a system could arise from random electrical fluctuations in a silicon chip. It requires intelligent design, meticulous programming, and constant debugging. DNA, with its error correction mechanisms, regulatory genes, and intricate protein synthesis pathways, is orders of magnitude more complex than any human-designed operating system. The idea that this highly sophisticated, self-replicating, and self-repairing information system could have assembled itself purely through random chemical reactions and natural selection stretches credulity. The origin of such specified, complex information, capable of encoding and executing the instructions for life, remains a formidable challenge for purely materialistic explanations, pointing towards an intelligent source. Reason 53. The problem of biological homochirality. Let's consider a subtle but profound mystery in the building blocks of life. Homochirality. Many biological molecules, like amino acids, the building blocks of proteins and sugars, components of DNA and RNA, exist in two mirror image forms like a left hand and a right hand. These are called enantiomers. In non-biological settings, chemical reactions typically produce an equal mixture of both left-handed and right-handed forms. However, in living organisms, almost all amino acids are left-handed, and almost all sugars are right-handed. This consistent preference for one chiral form over the other is called homochirality, and it's absolutely essential for life. Proteins wouldn't fold correctly, and enzymes wouldn't function if they were made of a mix of left and right-handed amino acids. The question is, how did this homochirality arise in the first place? How did the primordial soup, presumably a racemic equal mix, solution, suddenly select for and maintain a single chiral form? Random chance is astronomically unlikely to produce such a consistent bias. While some theories propose prebiotic mechanisms, none fully explain the origin and perpetuation of homochirality, suggesting a non-random, perhaps intentional, selection at the very dawn of life. Reason 54. The unexplained origin of photosynthesis. Imagine a process so fundamental that it underpins almost all life on Earth. Photosynthesis. This incredible biochemical pathway allows plants, algae, and some bacteria to convert light energy into chemical energy, producing oxygen as a byproduct. It's a marvel of engineering involving complex protein complexes, light harvesting pigments, and intricate electron transport chains. The evolution of photosynthesis is often presented as a gradual process, but the challenge lies in its irreducible complexity. For photosynthesis to work, multiple components must be present and functional simultaneously. The partially formed photosynthetic system offers no advantage. In fact, it could be detrimental. How did such a highly integrated and efficient system, with its numerous interdependent parts, rise through a series of small random mutations? A partially formed ribosome would be useless, unable to synthesize proteins, and thus offering no selected advantage. The sheer irreducible complexity of these fundamental molecular processes challenges the notion of gradual, undirected evolution, suggesting a pre-existing design or an intelligent assembly. Reason 64. The unexplained origin of biological repair mechanisms. Life is constantly under assault from internal and external threats. DNA damage from radiation, protein misfolding, cellular waste accumulation. Yet, living organisms possess an extraordinary array of repair mechanisms that maintain their integrity and function. DNA repair enzymes meticulously correct errors in our genetic code, molecular chaperones refold misfolded proteins, and cellular autophagy pathways recycle damaged organelles. These repair systems are themselves incredibly complex, involving multiple proteins and intricate regulatory networks. How did these sophisticated repair mechanisms, which are essential for long-term survival and the faithful transmission of genetic information, evolve gradually? A partially formed repair system would be effective, offering little or no selected advantage. The existence of such robust, pre-programmed repair and maintenance systems suggests a foresight or design that anticipates damage and builds in mechanisms to counteract it, rather than simply reacting to random occurrences. Reason 65. The problem of the origin of flight. The independent evolution of flight in insects, birds, and bats is a remarkable example of convergent evolution. However, the transition to flight is incredibly complex, requiring significant anatomical and physiological modifications. For birds, this includes the development of lightweight, hollow bones, specialized respiratory systems, feathers with intricate barb and barbial structures, and powerful flight muscles. For bats, it involves elongated finger bones supporting a membrane wing, and for insects, complex wing venation and musculature. Each of these adaptations, individually, might offer some minor advantage, but true flight requires the coordinated development of many interdependent features. A partially formed wing, or a bone that is only slightly hollow, offers no immediate advantage for flight and might even be a hindrance. The leap from non-flight to sustained, controlled flight, with all its necessary physiological and anatomical prerequisites, presents a significant challenge to gradualistic evolutionary explanations, suggesting a more rapid or orchestrated development. Reason 66. The unexplained origin of bioluminescence. In the depths of the ocean, in fireflies dancing on a summer night, and in certain fungi we encountered the enchanting phenomenon of bioluminescence, the production of light by living organisms. This process is not simple. It involves complex biochemical reactions, often requiring specific enzymes, luciferases, and light-emitting molecules, luciferins, along with precise regulatory mechanisms to control the light output. While bioluminescence can serve various functions, attracting mates, deterring predators, camouflage, the question remains: how did such a sophisticated biochemical pathway involving multiple interacting components, arise through random mutations. A partially formed bioluminescent system would not produce light and thus would offer no selected advantage. The intricate molecular machinery required for light production, often with high efficiency and specific wavelengths, suggests a level of biochemical engineering that is difficult to explain by purely undirected evolutionary processes. Reason 67. The problem of the origin of instincts and complex behaviors. Many animals exhibit incredibly complex, innate behaviors, instincts that are not learned, but are hardwired into their nervous systems. Consider the intricate nest-building behavior of birds, the precise migratory routes of monarch butterflies, or the elaborate mating dances of certain species. These behaviors are often highly specific, perfectly timed, and essential for survival and reproduction. How did such complex, pre-programmed behavioral sequences, involving intricate neural pathways and hormonal regulation, arise through random mutations in natural selection? A partially formed instinct might be maladaptive or useless. The coordinated development of the necessary neural structures, sensory inputs, and motor outputs to execute these behaviors, without prior learning or experience, suggests a level of pre-programming or design that challenges purely gradualistic evolutionary explanations. It points to an inherent, rather than acquired, intelligence in the animal kingdom. Reason 68. The unexplained origin of symbiotic relationships. Life is replete with examples of intricate symbiotic relationships where two different species live in close association, often to their mutual benefit. Consider the relationship between clownfish and sea anemones, where the clownfish is immune to the anemone's stinging tentacles and, in return, protects the anemone from predators, or the mycorrhizal fungi that associate with plant roots, exchanging nutrients for sugars. These relationships are often highly specific and involve complex adaptations on both sides. How did such interdependent relationships, requiring precise co-evolutionary steps and mutual adaptations, arise gradually? A partially formed symbiosis might offer no benefit or even be detrimental to one or both partners. The coordinated development of these reciprocal adaptations, where the success of one species is intricately linked to the other, suggests a level of pre-established harmony or design in nature that goes beyond random chance. Reason 69. The problem of the origin of consciousness in animals. While the hard problem of human consciousness is profound, the question of consciousness in animals also presents the significant challenge to evolutionary theory. Many animals, particularly mammals and birds, exhibit complex behaviors that suggest a level of subjective experience, emotion, and even self-awareness. Elephants mourn their dead, dolphins engage in complex social play, and primates demonstrate problem-solving abilities and empathy. If consciousness is merely a byproduct of brain complexity, at what point on the evolutionary scale did it emerge? Is there a clear dividing line between conscious and non-conscious beings? The apparent continuity of conscious experience across different species, with its varying degrees of complexity, suggests a fundamental property of life that is not easily explained by purely mechanistic, survival-driven evolutionary models. It hints at a deeper, non-material dimension to animal existence. Reason 70. The unexplained origin of the placebo effect. The placebo effect is a well-documented phenomenon where a patient's belief in a treatment can lead to real physiological improvements, even if the treatment itself is inert. This demonstrates the profound power of the mind to influence the body. From an evolutionary perspective, the placebo effect is puzzling. Why do our bodies evolve a mechanism to heal themselves based on belief alone? While some argue it's a byproduct of our capacity for hope and expectation, the sheer specificity and power of the placebo effect, which can mimic the effects of powerful drugs, suggests a deeper mind-body connection but is not easily explained by purely materialistic, survival-driven evolution. It points to a level of self-healing and mental influence over our biology that transcends the traditional boundaries of physical cause and effect, hinting at a non-material dimension to our being. Reason 71. The problem of the origin of music and art. The human drive to create and appreciate music and art is a universal and deeply ingrained aspect of our nature. From the earliest cave paintings to the grand symphonies of today, we are a species that seeks beauty, expresses emotion, and tells stories through artistic creation. From an evolutionary perspective, the origin and persistence of these behaviors are difficult to explain. While some theories suggest that art and music may have played a role in social bonding or sexual selection, they often fail to account for the profound emotional and spiritual experiences that these art forms evoke. Why do we find beauty in abstract patterns? Why does a particular melody bring us to tears? The human capacity for aesthetic experience, which often seems to have no direct survival value, suggests a dimension of our being that transcends the purely utilitarian, pointing towards a deeper, non-materialistic source for our creativity and our appreciation of beauty. Reason 72. The unexplained origin of dreams and the subconscious mind. Every night we enter a world of dreams, a realm of vivid imagery, strange narratives, and profound emotions. The subconscious mind from which dreams arise is a vast and mysterious landscape that continues to elude full scientific understanding. While some evolutionary theories propose that dreams are a way to process memories, solve problems, or simulate threats, these explanations often fall short of capturing the full richness and symbolic depth of our dream lives. Why do we have recurring dreams? Why do we experience such intense emotions in our dreams? The existence of a complex, creative, and often insightful subconscious mind, which operates outside our conscious control, presents a significant challenge to purely materialistic models of the brain. It suggests a dimension of our mental life that is not fully accounted for by the survival-driven imperatives of evolution, hinting at a deeper, non-physical aspect of our consciousness. Reason 73. The problem of the origin of laughter and humor. Laughter is a universal human expression, a spontaneous and often uncontrollable response to humor. But why do we laugh? From an evolutionary perspective, the origin of humor and laughter is puzzling. While some theories suggest it may have evolved as a social signal to indicate safety or to strengthen group bonds, these explanations don't fully account for the cognitive complexity of humor, the ability to appreciate irony, satire, and wit. The fact that we can find amusement in abstract concepts, unexpected juxtapositions, and clever wordplay suggests a level of cognitive sophistication that goes beyond simple social signaling. The existence of humor, with its capacity to bring joy, relieve stress, and foster connection, points to a dimension of human experience that is not easily explained by purely survival-driven evolution, hinting at a deeper, more playful aspect of our nature. Reason 74. The unexplained origin of play behavior in animals and humans. Play is a common behavior in many animal species, especially mammals and birds. From a kitten chasing a ball of yarn to a group of dolphins leaping through the waves, play is a seemingly frivolous activity with no immediate survival benefit. While some evolutionary theories suggest that play is a way to practice hunting skills, develop social bonds, or burn off excess energy, these explanations don't fully capture the joyful, spontaneous, and often creative nature of play. Why do animals engage in activities that are not directly related to feeding, mating, or fighting? The existence of play, with its emphasis on enjoyment and exploration, suggests a dimension of animal life that transcends the purely utilitarian, hinting at a capacity for joy and a motivation beyond mere survival. Reason 75. The problem of the origin of individuality and personality. While we share a common genetic heritage, Each of us is a unique individual with a distinct personality, temperament, and set of preferences. Even identical twins who share the same DNA often exhibit significant differences in their personalities and life choices. From an evolutionary perspective, the origin of such a wide range of individuality is not fully understood. While genetic variation and environmental factors play a role, they don't completely account for the subtle nuances of our personalities, our sense of humor, our passions, our fears. The existence of such a rich tapestry of human individuality, with its capacity for creativity, self-expression, and personal growth, suggests a dimension of our being that is not fully determined by our genes or our environment, hinting at a deeper, non-material source for our unique sense of self. Reason 76. The unexplained origin of the human sense of justice and fairness. Humans have an innate sense of justice and fairness, a deep-seated belief that people should be treated equitably, and that wrongdoing should be punished. This sense of justice is not simply a matter of social convention. It's a powerful moral intuition that can drive us to protest injustice, even at great personal cost. From an evolutionary perspective, the origin of this abstract sense of justice is difficult to explain. While some theories suggest it may have evolved to promote cooperation and social stability, they don't fully account for our capacity to apply principles of justice to hypothetical situations or to feel outrage at injustices that don't directly affect us. The existence of a universal human yearning for justice, with its emphasis on moral principles and abstract reasoning, suggests a dimension of our being that transcends the purely pragmatic, hinting at a deeper, non-material foundation for our moral lives. Reason 77. The problem of the origin of beauty in nature. The natural world is filled with breathtaking beauty, from the intricate patterns of a butterfly's wing to the majestic grandeur of a mountain range. While some evolutionary theories attempt to explain our appreciation of beauty in terms of its association with survival cues, a lush landscape indicates the presence of food and water. These explanations often fall short of capturing the full depth of our aesthetic experience. Why do we find beauty in things that have no obvious survival value, like a sunset or a field of wildflowers? Reason 82. The unexplained origin of the human sense of awe and wonder. Humans have a unique capacity for awe and wonder, the ability to be moved and inspired by the vastness and beauty of the universe. Whether we're gazing at a star-filled night sky, witnessing a powerful thunderstorm, or contemplating the intricate complexity of a living cell, we are often filled with a sense of something greater than ourselves. From an evolutionary perspective, the origin of this profound emotional experience is difficult to explain. While some theories suggest it may have evolved to promote social cohesion or to encourage exploration, they don't fully capture the transcendent, often spiritual, quality of awe. The existence of our capacity for awe and wonder, with its power to connect us to a sense of mystery and meaning, suggests a dimension of our being that transcends the purely utilitarian, hinting at a deeper, non-material aspect of our consciousness. Reason 83. The problem of the origin of biological regeneration. Some animals, like salamanders and starfish, have the remarkable ability to regenerate lost limbs and even entire organs. This process of regeneration is incredibly complex, involving the coordinated activation of stem cells, the precise patterning of new tissues, and the integration of the new body part with the existing one. From an evolutionary perspective, the origin of this sophisticated regenerative capacity is a profound mystery. How did the genetic and molecular machinery for such complex regeneration, which is often lost in more advanced species like mammals, arise in the first place? A partially formed regenerative ability would be ineffective. The existence of this remarkable capacity in certain species, which seems to defy the general trend of increasing complexity and specialization, suggests the deeper, perhaps ancestral, potential for healing and renewal that is not fully explained by standard evolutionary models. Reason 84. The unexplained origin of the human capacity for storytelling. Humans are a storytelling species. We create narratives to make sense of the world, to share our experiences, and to connect with each other on a deeper level. From ancient myths and legends to modern novels and films, storytelling is a universal and deeply ingrained aspect of our culture. From an evolutionary perspective, the origin of this complex cognitive and social behavior is not fully understood. While some theories suggest that storytelling may have evolved as a way to transmit information, promote social cohesion, or practice problem solving, they don't fully account for the profound emotional and imaginative power of narrative. Why are we so drawn to stories? Why do they have the power to move us, inspire us, and change our perspectives? The existence of our capacity for storytelling, with its ability to create shared meaning and to explore the depths of the human experience, suggests a dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our consciousness. Reason 85. The problem of the origin of biological symmetry. Symmetry is a ubiquitous feature of the biological world, from the bilateral symmetry of most animals to the radial symmetry of flowers and starfish. This underlying order and pattern is not just aesthetically pleasing, it's often essential for function. For example, the bilateral symmetry of our bodies allows for balanced movement, and the radial symmetry of a flower helps to attract pollinators from all directions. From an evolutionary perspective, the origin of these highly ordered and often complex symmetrical patterns is a profound mystery. How did the genetic and developmental programs for creating such precise and consistent symmetry arise through random mutations? While some simple physical and chemical processes can generate symmetrical patterns, the intricate and functionally integrated symmetry of living organisms suggests a deeper, perhaps inherent, organizing principle at work. The pervasiveness of symmetry in the biological world, which often seems to go beyond what is strictly necessary for survival, hints at an underlying mathematical and aesthetic order that is not fully explained by purely utilitarian evolutionary models. Reason 86. The unexplained origin of the human capacity for hope and optimism. Despite the challenges and uncertainties of life, humans have a remarkable capacity for hope and optimism, the ability to believe in a better future and to persevere in the face of adversity. This innate tendency to look on the bright side is not simply a matter of wishful thinking. It's a powerful psychological resource that can improve our health, enhance our relationships, and increase our chances of success. From an evolutionary perspective, the origin of this cognitive bias towards optimism is not fully understood. In a world filled with dangers and uncertainties, a more realistic or even pessimistic outlook would seem to be a more adapted strategy. While some theories suggest that optimism may have evolved to motivate us to take risks and explore new opportunities, they don't fully account for the profound sense of resilience and meaning that hope can provide. The existence of our capacity for hope and optimism, with its power to sustain us through difficult times and to inspire us to create a better world, suggests a dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our humanity. Reason 87. The problem of the origin of biological rhythms beyond circadian. While circadian rhythms are well studied, living organisms exhibit a wide range of other biological rhythms, from the ultradian rhythms of hormone release that occur multiple times a day to the infradian rhythms of menstrual cycles and seasonal migrations that occur over longer periods. These rhythms are not simply passive responses to environmental cues. They are generated by internal, self-sustaining oscillators that are precisely tuned to the specific needs of the organism. From an evolutionary perspective, the origin of this complex hierarchy of biological rhythms is a profound mystery. How did the intricate molecular and neural mechanisms for generating and coordinating these multiple rhythms, each with its own specific period and phase, arise through random mutations? A partially formed or uncoordinated rhythmic system would be maladaptive. The existence of this rich and complex temporal organization in living organisms, which allows them to anticipate and adapt to a wide range of predictable environmental changes, suggests a level of pre-programmed design that challenges purely gradualistic evolutionary explanations. Reason 88, the unexplained origin of the human capacity for self-transcendence. Humans have a unique capacity for self-transcendence, the ability to feel connected to something larger than ourselves, whether it's nature, humanity, or a higher power. This experience of self-transcendence, which is often accompanied by feelings of awe, wonder, and profound meaning, is a central component of many spiritual and religious traditions. From an evolutionary perspective, the origin of this profound psychological experience is difficult to explain. Why would we evolve a capacity to feel a sense of connection that seems to diminish the importance of our individual survival and self-interest? While some theories suggest that self-transcendence may have evolved to promote group cohesion or to reduce anxiety, they don't fully capture the transformative and often life-changing power of these experiences. The existence of our capacity for self-transcendence, with its ability to connect us to a sense of purpose and meaning beyond our individual lives, suggests a dimension of our being that is not fully accounted for by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our consciousness. Reason 89. The problem of the origin of biological navigation systems. Many animals, from migratory birds and sea turtles to monarch butterflies and salmon, have the remarkable ability to navigate vast distances with incredible accuracy. They use a variety of cues, including the Earth's magnetic field, the position of the sun and stars, and olfactory signals, to find their way to their breeding and feeding grounds. These biological navigation systems are incredibly complex, involving specialized sensory organs, sophisticated neural processing, and an innate sense of direction. From an evolutionary perspective, the origin of these highly integrated and finely tuned navigation systems is a profound mystery. How did the genetic and molecular machinery for sensing and interpreting these subtle environmental cues and for translating them into precise navigational decisions rise through random mutations? A partially formed navigation system would be useless. The existence of these remarkable navigational abilities in a wide range of species, which often seem to defy our current understanding of sensory biology, suggests a level of pre-programmed design that challenges purely gradualistic evolutionary explanations. Reason 90. The unexplained origin of the human capacity for gratitude. Gratitude is a powerful human emotion, the ability to appreciate the good things in our lives and to feel thankful for the kindness of others. It's a cornerstone of positive psychology, with numerous studies showing that practicing gratitude can improve our well-being, strengthen our relationships, and increase our resilience. From an evolutionary perspective, the origin of this pro-social emotion is not fully understood. While some theories suggest that gratitude may have evolved to promote reciprocity and strengthen social bonds, they don't fully account for the profound sense of connection and meaning that gratitude can evoke. Why do we feel a sense of thankfulness for things that are not directly related to our survival, like a beautiful sunset or a moving piece of music? The existence of our capacity for gratitude, with its power to shift our perspective from what we lack to what we have, suggests a dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our humanity. Reason 91. The problem of the origin of biological adhesives. Many organisms, from bacteria and barnacles to mussels and geckos, have the remarkable ability to produce powerful adhesives that allow them to stick to a wide variety of surfaces, even underwater. These biological adhesives are incredibly complex, often involving a precise mixture of proteins and other molecules that are secreted and then cured to form a strong bond. The properties of these adhesives are often finely tuned to the specific needs of the organism, with some being permanent and others being reversible. From an evolutionary perspective, the origin of these sophisticated biochemical systems is a profound mystery. How did the genetic and molecular machinery for producing and deploying these complex adhesives, with their precise chemical compositions and material properties, arise through random mutations? A partially formed adhesive would be effective. The existence of these remarkable biological adhesives, which often outperform our own synthetic adhesives, suggests a level of biochemical engineering that challenges purely gradualistic evolutionary explanations. Reason 92: the unexplained origin of the human capacity for empathy. Empathy is the ability to understand and share the feelings of another person. It's a cornerstone of our social and emotional lives, allowing us to connect with others, build relationships, and act with compassion. From an evolutionary perspective, the origin of this complex cognitive and emotional capacity is not fully understood. While some theories suggest that empathy may have evolved to promote cooperation and group cohesion, they don't fully account for our ability to empathize with individuals who are not part of our immediate social group, or even with members of other species. Why do we feel a pang of sadness when we see a stranger in distress? Why are we moved by stories of suffering from around the world? The existence of our capacity for empathy, with its power to transcend the boundaries of self-interest and to connect us to a shared sense of humanity, suggests a dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our consciousness. Reason 93: the problem of the origin of biological coloration and camouflage. The natural world is filled with a stunning array of colors and patterns, from the vibrant plumage of a peacock to the intricate camouflage of a chameleon. This biological coloration is not simply a matter of random pigmentation. It's often a highly sophisticated and functionally integrated system that serves a variety of purposes, including communication, mating displays, and predator avoidance. The mechanisms for producing these colors are incredibly diverse, ranging from pigments that absorb certain wavelengths of light to structural colors that are created by the physical interaction of light with microscopic structures. From an evolutionary perspective, the origin of these complex and often beautiful coloration systems is a profound mystery. How did the genetic and developmental programs for creating such precise and often dynamic patterns of coloration arise through random mutations? A partially formed camouflage or a slightly off-key mating display would be effective. The existence of such a rich and diverse palette of biological coloration, which often seems to go beyond what is strictly necessary for survival, suggests a level of artistry and design in the natural world that is not fully explained by purely utilitarian evolutionary models. Reason 94: the unexplained origin of the human capacity for humor and playfulness. Humans have a unique capacity for humor and playfulness, the ability to find amusement in the absurd, to appreciate wit and irony, and to engage in activities that have no immediate practical purpose. Laughter, the physical expression of humor, is a universal human behavior that is present from a very early age. From an evolutionary perspective, the origin of this seemingly frivolous aspect of our nature is difficult to explain. While some theories suggest that humor and play may have evolved as a way to strengthen social bonds, reduce stress, or practice cognitive skills, they don't fully account for the sheer joy and creativity of these behaviors. Why do we tell jokes? Why do we play games? The existence of our capacity for humor and playfulness, with its power to bring us joy, foster connection, and spark creativity, suggests a dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, more light-hearted aspect of our humanity. Reason 95: the problem of the origin of biological sensors. Living organisms possess an incredible array of biological sensors that allow them to perceive and respond to their environment. From the photoreceptors in our eyes that detect light to the chemoreceptors in our noses that detect odors, these sensors are exquisitely sensitive and highly specific. They are often composed of complex protein molecules that change their shape in response to a specific stimulus, triggering a cascade of signals that ultimately leads to a behavioral or physiological response. From an evolutionary perspective, the origin of these sophisticated molecular sensors is a profound mystery. How did the genetic and molecular machinery for creating such highly specific and sensitive sensors with their precise binding sites and signal transduction pathways arise through random mutations? A partially formed sensor would be non-functional. The existence of such a diverse and finely tuned array of biological sensors, which allow organisms to navigate their world with incredible precision, suggests a level of pre-programmed design that challenges purely gradualistic evolutionary explanations. Reason 96, the unexplained origin of the human capacity for moral reasoning. Humans have a unique capacity for moral reasoning, the ability to think about ethical principles, to make judgments about right and wrong, and to justify our moral beliefs. This capacity for moral reasoning is not simply a matter of following social norms or emotional intuitions. It involves a complex process of abstract thought, logical deduction, and the application of universal principles. From an evolutionary perspective, the origin of this high-level cognitive ability is a profound mystery. While some theories suggest that moral reasoning may have evolved to promote cooperation and resolve conflicts, they don't fully explain our capacity to reason about complex ethical dilemmas or to develop sophisticated moral philosophies. The existence of our capacity for moral reasoning, with its emphasis on abstract principles and logical consistency, suggests a dimension of our being that transcends the purely pragmatic, hinting at a deeper, non-material foundation for our moral lives. Reason 97. The problem of the origin of biological pumps and motors. The cells of living organisms are filled with a variety of molecular pumps and motors that are essential for life. These tiny machines transport molecules across membranes, power the movement of cilia and flagella, and drive the synthesis of ATP, the energy currency of the cell. They are incredibly efficient and highly specific, often operating with near-perfect accuracy. From an evolutionary perspective, the origin of these sophisticated molecular machines is a profound mystery. How did the genetic and molecular machinery for creating such complex and highly coordinated pumps and motors, with their intricate protein structures and precise energy coupling mechanisms, arise through random mutations? A partially formed pump or motor would be non-functional. The existence of these remarkable molecular machines, which are essential for the most basic processes of life, suggests a level of biochemical engineering that challenges purely gradualistic evolutionary explanations. Reason 98, the unexplained origin of the human capacity for love and compassion. Love and compassion are two of the most powerful and profound human emotions. They are the foundation of our most meaningful relationships, and they inspire us to act with kindness, generosity, and self-sacrifice. From an evolutionary perspective, the origin of these pro-social emotions is not fully understood. While some theories suggest that love and compassion may have evolved to promote pair bonding, parental care, and group cohesion, they don't fully account for our capacity to feel love and compassion for individuals who are not our kin, or even for members of other species. Why do we form deep emotional bonds with others? Why are we moved to help those who are suffering? The existence of our capacity for love and compassion, with its power to connect us to a sense of shared humanity, and to inspire us to create a more just and caring world, suggests that the dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our humanity. Reason 99, the problem of the origin of biological complexity in the fossil record. The fossil record, while incomplete, provides a glimpse into the history of life on Earth. One of the most striking features of the fossil record is the sudden appearance of complex life forms in the Cambrian explosion, about 540 million years ago. In a relatively short period of geological time, most of the major animal phyla appeared, with a wide range of body plans and complex anatomical features. This sudden burst of biological innovation, with little or no evidence of evolutionary precursors, presents a significant challenge to the gradualistic model of evolution. While some theories propose that the Cambrian explosion was preceded by a long period of hidden evolution, the fossil record as it currently stands suggests a more abrupt and creative process. The sudden appearance of such a wide range of biological complexity, with no clear evolutionary antecedents, hints at a more rapid or even orchestrated origin of life's major body plans. Reason 100. The unexplained origin of the human search for meaning and purpose. Humans are a meaning-seeking species. We have a deep-seated need to understand our place in the universe, to find a sense of purpose in our lives, and to believe in something larger than ourselves. This search for meaning is a universal human drive, one that has inspired the creation of art, religion, philosophy, and science. From an evolutionary perspective, the origin of this existential quest is a profound mystery. Why would we evolve a need for meaning and purpose that often seems to have no direct survival value? While some theories suggest that the search for meaning may be a byproduct of our large brains or our complex social lives, they don't fully account for the profound sense of fulfillment and well-being that comes from living a life of purpose. The existence of our innate desire for meaning, with its power to guide our choices, shape our values, and give our lives a sense of direction, suggests the dimension of our being that is not fully explained by the survival-driven imperatives of evolution, hinting at a deeper, non-material aspect of our humanity. You made it. 100 reasons. 100 whispers against the noise. And maybe, just maybe, something deeper than randomness has always been behind the curtain. You're not an accident, not a lucky mutation. You are here, on purpose.